Okay, so here we see another example of an efficiency problem. The reason we know that is a lot of you had pointed out this is not asking any question. Okay, so at the end we said, what is the efficiency of this? You want to call it tow truck, or this tow truck that maybe has a flatbed that would elevate up like this. And when we do that, that creates an inclined plane. So upon visualizing that, let's see here, let me get hopefully a marker that we can see, just like yesterday, but we'll go the opposite direction this time. Okay, so there's our inclined plane. So the flatbed of this truck must be lifted up. So how high did that flatbed get lifted up? Okay, so it got lifted up 2.40 meters, but maybe we should start by reading the problem. My mistake. Okay, a tow truck can pull a car onto a trailer with 6,010 newtons. Okay, the trailer is 8 meters long, and the height is 2.4 meters, 2.40. The car has a mass of 1720 kilograms. So what is the efficiency of this machine? Okay, now typically what happens is, doesn't state this in the problem. I was going to write that in, but I was afraid that it might confuse you. A lot of these, they're called a winch. That's a lot of, I think, highway patrol vehicles, maybe different deputies or any type of law enforcement out on patrol has a cable. What would you, do you know what I'm talking about? How would you describe it to your classmates? How about a spool? Okay. And on this spool, there's a cable wrapped around here. Okay. So what happens is you pull on that spool, there's a cable on there, you attach that cable onto a vehicle that might be stranded. So then what happens is then through the course of pressing a button on this machine, this winch, it has probably 40 horsepower on it. Okay? I was going to say this winch has 40 horsepower on there, but I thought that might confuse you, so I left that out. Okay. So when we draw this out, we had said that if you're having problems solving this, maybe drawing a type of situation on here or a diagram just might help. Okay, so here's our vehicle on here. I'm not going to try to draw a car because I'm just not that artistically talented. Of course, we could just put this box, and there's our wheel well on there. Maybe it's a bus, but the mass of that would be, of course, much, much bigger. Okay, so this vehicle is getting pulled onto the back of the trailer. Okay, so what is giving that car its weight? We give you a mass, but that's not its weight. And that's right, because what's another way of measuring weight besides pounds? Kilograms is a mass. That's not a weight. Okay? Our example that we gave is if you have a semi-truck parked next to your vehicle, which one is heavier? Because that has a far greater mass, right? So the bigger the mass, the heavier the object's going to be, because that bigger mass is having gravity acting upon it. So this vehicle, which has a mass of 1720 kilograms, okay, what is exerting on that 1720 kilograms to give it its weight? So you said it already, gravity, okay? So that is pulling down on here at 9.8 meters per second squared, okay? So now, what is the length of that trailer? What does it tell us in here? Is it 2.4 meters long, or is it 8 meters long? Okay, so it gives us this number here, 8 meters long. Okay, so here's our trailer, 8 meters long. So then once that flatbed lifted from being flat to this inclined plane, how high did that lift? 2.4 meters. That's right. Okay. Then this winch or machine that's attached up to here is pulling on that vehicle. Okay. A tow truck can pull a car onto its trailer or flatbed with 6,010 newtons. So if this is pulling on this vehicle, 6,010 newtons. Okay? What type, if it's measured in newtons, that's telling you something very specific. What would that be? Any force is measured in newtons. Okay? Okay, we'll come back to that. Okay? So what is your formula for this? Okay, we said the right variables, but in the wrong order. Okay? So once we have our formula here that we have, and these variables in here, okay, when this is being pulled up with 6,010 newtons, is that, we know it's a force, is that a resistance force or is that an effort force, that machine pulling on that vehicle? Is that resistance or is that effort? Okay? We place effort into a lot of things, you know, lifting weights, doing well in sports, doing well in school. Okay? We're always putting effort into things, and that's what we see happening here. You have 6,010 newtons of effort force pulling that vehicle on there. Okay? So here are our variables. So we correctly said, which type of force is this? Resistance or effort? That is your effort force. Because, again, that is pulling on that vehicle with that much force. So that is an effort force. Okay? So for how long is this winch or machine pulling on that vehicle? Well, it would be the length of your trailer, which in the problem it says what? 8 meters. Okay? Okay? Then, again, this flatbed was flat, but then it lifted up to make this inclined plane, and upon doing so, what is the height of that ramp now? 2.4, which means that incline there is having gravity acting upon it, and therefore it gives it a resistance of 2.4, oops, it's in the wrong spot. 2.40 meters. But notice we don't have anything left that's labeled in newtons like what we do here, because we know we have to have a force because it says it right here. We need one more variable. But what happens when you take any mass times any acceleration? It becomes a force. Of course, of course. Is that something like Mr. Ed? I don't know. I think that. Too bad Mr. Ed's not here. Do you know that's a talking horse? I don't think you've ever heard of Mr. Ed, have you? No? All right. Okay. I'll keep going. Okay. So 1720 times 9.8. Okay. Gives you 16,856. 16,856 newtons. Okay. Now, think of how far, hopefully we've come in understanding of this since the first time that you've seen this. With any problem, we hope that once you get this setup done, the last thing you have to do is just what that formula tells you to do. Okay? So to complete this then, what do we put on top of our fraction there? Okay, so 16,856 times what? Times whatever our setup says, 2.40. Okay. That was close. Okay. Then what's on the bottom there? 6,010 times what? Whatever our effort distance was. That effort distance was how long that's being pulled up that ramp. And in this case, it's 8 meters. Okay. So we've got 16,856. And we're going to take that times 2.40. And that's going to give us 40,454. Okay? But keep in mind, just as a review, if this is a force and if this is a distance, sorry, I'm stuttering. What happens when you take any force times any distance? That was the first type of problem we learned about in this chapter. You get work, okay? So efficiency is another way of writing work out divided by work in, but that's for another time and another place because any force times a distance gives you work. Okay, so what's on the bottom of our fraction now? Well, whatever 8 times 6,010 is, 6,010 times 8 gives you 48,080. Okay?
How come we don't flip it around because you take that divided by the bigger number to get your percentage?
Yeah, well, it's just these two numbers on the bottom according to our equation here. That's why they're on the bottom. Okay? One of the things I want you to think about is, okay, to me, the best way to describe this is there's no such thing as a perfect machine. In other words, however much work you put into it, you're not going to get 100% of work output on it. Okay? So probably the biggest drawback on machines is friction. Okay? That could be one. Okay? That's probably not just one, but that's the major reason that machines can't be 100% efficient because there's just too much friction to overcome that. Okay? So think of inside your vehicle, inside inside your motor or engine, whichever you call it, motor or engine. Okay? You have these funny things that move up inside. What are they called? Starts with a P. Those are called pistons. And sometimes you have these pistons in 4 of these, sometimes you have them in 6 of these, and sometimes you have them in 8 of these. And if you're lucky enough to have a Lamborghini, you might have them in 12 of them. Those pistons are inside of what? Cylinders or valves. You might have a V6, a V8, there's V10s, and of course there's V12s. So why is it that a V12 would have way more power than a V6? You have a lot more pistons going up and down to supply work. But what do you need to I just happened to catch that out of the corner of my eye. With that, inside your valve, your pistons are going up and down. Why do you put oil in your engine? To reduce friction. Okay? Because if you don't, you're going to ruin your engine. Okay? That's why, I think we had asked this before. How many of you just rely on the mileage or the sensor on your vehicle that says low engine oil? Or how many of you actually lift the hood, find the dipstick? Oh, there he is. Okay? So how many of you know what a dipstick is? Okay? Now the big one. How many dipsticks does your vehicle have? How many dipsticks does your engine have? How many dipsticks does your engine have? It's a trick question. It'll make sense when I tell you. Why would there be two? One for the engine oil. Starts with the T. You have transmission fluid in there too. But the trick with that is you can't check your transmission fluid unless your engine's running. Okay, so what happens when you divide these two out? 40,454 divided by 48. 84%. And again, that has no label to it. It's just 84%. Okay. Front row, are we on the bus here? Second row, are we on the bus? If you're doing this or nodding your head yes, is that okay? She went like that already. Okay? All right. So if you don't understand this, I mean, you might have noticed walking in here, there were still some students taking an exam from last hour. Okay? Science is hard. Okay? But what do we get from you volleyball players? This will make sense. What happens? Who's the easiest opponent that you lady volleyball players have played? Your team? Canastota. Okay? So what would happen if just the regular season you played Canastota 15 times? But once after the 15th time, now you got to go play Chester. Now you got to go play Sioux Falls Lutheran. Now you got to go play Bridgewater Emory or Castlewood or Faith. What happens if you face an opponent that's easy so much you claim, then all of a sudden now you got to play someone of that caliber? You're probably going to get demolished. Okay? So our approach here is when you move on in the future, we don't want you to get demolished. We could just be easy on you and just say, let's just send you on your way. Everyone gets a good grade. And when you go to college and take this, oh my gosh, we didn't learn anything in high school because it was just too easy. Anyone can take the easy way out, but that's not the right way to approach it. Okay. So can I erase this? Okay. Make sure that gets picked up, please. Okay, there's a new problem up on the board. Okay, HP is horsepower. Okay, that's what we have on today's schedule is calculating horsepower. Now, this is just saying how big this John Deere is. Okay, so it's just a model number. So I'm thinking, or I should say, and hoping that this works out because I just started writing this problem out. Hopefully we get a big number, not just because John Deere is the best, right? But just because we want it to be somewhat accurate. Okay. No, this problem isn't going to make any sense, but the way that we get the answer does. Okay.
You really think I want to hang out with the country butters?
Okay, so a new formula for you.
Another one? Yeah. I think that I'm not. I already don't understand this. I don't even know how to find the other ones.
Okay.
That's the formula. Do you always divide by
Yes, you do. You always divide by that. Okay? So, yes.
tomorrow? Yes.
We have a test tomorrow.
Yes, you do. Okay?
I know, literally. Guys, they're not the same thing.
Okay. Now, one of the things we're doing in another class, we spent so much time on these problems, so we're going to perhaps beat you to, I'm just going to write this down here, vocab quiz on 11/7. Okay? So what does that mean to you? Okay? So I'm just going to put a line through there. Okay? So next week, Tuesday, is November 7th. That's when we're going to have your evaluation. All right? Okay. So this new equation is based off of old information. Okay? Because, okay, what in here do we know how to do? We know how to calculate power. That's right. Okay? So, when you look at that number 746, it's just a constant. And this is how I like to explain constants. Okay? In other words, if you needed to find the circumference of this circle, at some point you need to multiply by what variable? You know this, you just don't know you know it. Say that again. You have to multiply that funny looking symbol, that's pi. So in other words, pi is a constant, okay? In any circle, in any cylinder, in any cone, and in any sphere, you have to multiply by this constant at some point. 3.14 is a constant. 746 is also a constant. We're just trying to rationalize this and explain to you.
What is 746 equals power divided by what?
746.
Oh, it's 746?
Yes. Okay. 746? It's just a constant. Don't you have to multiply by that to find the circumference of a circle at some point? Because it's pi.
What does that number mean?
This number here,
Random number.
it's just a constant. Yeah, you could say it's a random number. You always have to use 746. Okay. All right. So we've read the problem. What do we know in this problem? What else do we know? Kind of ran out of space there, but there has to be, you can't just jump right into this equation, okay? Because first of all, in order to calculate power, you need to know how much what you're doing first. You have to know how much work you're doing, okay? Hopefully this looks a little familiar, right? Does this look familiar or not?
Yeah.
Okay, so once we solve for this, that number goes over here. Okay, so that's what I mean. This problem is based off of old information that you know how to do. Okay, so how can we calculate the work in this problem? Russell, I can just start writing up this and just saying this is how you do it and then let you fill in the gaps. Do you want my help or not? No? Okay. Last chance. Do you want our help or not? Okay. Was that hard to nod our head yes? I don't think it was a Herculean task, but maybe it was. Okay. So how are we going to calculate our work that we need to find down here? Force times distance. Okay, but how can we calculate the force? Mass times acceleration. Okay, so we have a mass, we have an acceleration. So what do we get when we take 4.10 times, I don't know why I had 670 there. I think I just wrote that number twice. Did anyone else write 670 there? Okay, let's change that because, okay, so since we need to change that anyway, let's lower that down to 4,000. Let's try that.
Kilograms.
So change this to 4,000. Okay? Okay. All right. Okay. What do we get for an amount of work?
I don't know how to redo it.
Oh, okay. Well. Okay. So 4,000 times 410.
No, that's force.
Okay, so now that we have our force, now we can take 16,400, okay, times our distance, which was 670, okay, so 16,400, that's our force times our distance, 670. It is a big number. Okay? So what is work measured in? Joules. Okay? So once we have something measured in joules or our work, what do we divide by to get our power? 55, okay? So once we divide this by 55, okay, our work divided by our time gives us power, okay? So that big number divided by 55, you're still going to have a fairly large number. No, it's just the number, just like percentage for efficiency. No, it's not a percentage. It's just a number. Just like you would say, so 267 horsepower. We will catch up to you next time. We'll have a paper for you that was supposed to be handed out yesterday. We'll keep that for tomorrow, so we'll catch up to you next time.